Okay, sure. Hello, everyone. Welcome to my presentation on Azure machine learning model deployment, monitoring, and data drifting. I'm Rahat Yasir. I will tell more about my background and everything a bit later. And thank you for inviting me at Global AI Bootcamp of 2021. So this is the first session of the year. So very excited. Before starting the presentation, I'm already going through a lot with my work and everything. So I was thinking like a few times about the content and how should I like present, because those topics, model deployment, monitoring, data drifting, are kind of like a bit advanced, because not everyone working in the data science and AI domain are working with those specific like technologies or terms. So without talking anymore, like let's just like jump into the presentation and see a couple of like small demos. So if I just give my small brief, I'm working as AI platform architect at CAE. Mostly works in the aviation and like aerospace, but it's been like 8 to 10 years I'm working in the AI and data science domain. Worked at different companies like OCDI, Intac, Immersive Design, P2IRC as a research scientist, and others. And it's been like 6 times that I'm a Microsoft Most Valuable Professional in AI, and I got Canada's Top Dev 30 under 30 in 2018. Okay, so what we are gonna cover today. So today we will talk about AI lifecycle, because like before talking about deployment, monitoring, and data drifting, it is very important to know and just review the AI lifecycle. And we'll talk a bit very high level about Azure machine learning, and then we'll talk about Azure model deployment, why we need that one. Then we'll talk a bit about Azure model monitoring and data drifting, and then we'll give like a small demo on Azure machine learning with the automated machine learning model deployment, plus something custom model deployment on that Azure ML platform. And also we will show how model monitoring and data drifting works, and what is it. And then at the end we can have like a small Q&A session if there is anything. Okay, so AI domain and boundaries. Our life is actually surrounded by AI from every possible ways. Whether we think like, okay, AI is not for everyone, AI is just for cool stuff. Not really. AI is actually used like literally in every corner, like from our mobile phone to surveillance to different kind of commercial application that we are using, like search engine, chatbots, personalized shopping experience, insurance premium, robot assistance, utility demand, fraud detection of our banking like transactions, and surveillance. Every corner is used, like all those applications are perfect examples of AI. And whether we accept it or not, our life is right now surrounded by AI models. But in most of the cases, those are shallow or narrow AI, where those AI models are designed to serve just one purpose, and that's what we are doing. Just like suppose the if you are an iPhone user, you are using facial recognizer. So there is one model when you first started your iPhone and configured your iPhone. That model was designed just to identify your face and detect whether like whenever there is a face in front of it, whether it's the face of the owner or not. It's a two-class classifier. So it is already installed, it is already designed, and when you first use it, you have retrained that one with your own facial data. So then every time you're unlocking your iPhone, you are using this facial recognition computer vision based model. So what happened? One thing is when we talk about AI, we or data science, we hear a lot about model or training or testing or validation. But one of the most important part of any kind of AI is model deployment or model using. So you can train the best model in the world, but if you don't use that model, then that model is useless, and that model is not bringing any kind of business value. That model is not offering anything new. So or connecting with your client devices or mobile app or your web application, then that model is not like you're not using it. So it's not like so we need to know how to deploy the model, how to use the model, what are the process of using this model, connecting it with your mobile or web or client facing applications. And also we need to know, after deploying the model which you have connected with your existing applications, when it is to retrain the model, and when you will have to refine tune or do something, or when the model is already done, you cannot use it anymore, it is giving garbage results. So you need to know those informations, which is covered by model deployment, model monitoring, and data drifting, that we are going to talk about today. Okay. um, as we talk, say, I have said at the beginning that we will talk about Azure, any kind of AI application development lifecycle or AI lifecycle. So this is end-to-end machine learning pipeline or AI lifecycle looks like. So I'm not going to talk too much about this first one, preparing data or build and training data. In our previous sessions with Azure India, we have already talked about those topics and covered them. But today, mostly we will talk about model deployment, prediction, and model monitoring. This the third part, because last presentation I believe we didn't get much time to cover this side. So if we talk about application, if you're new in this domain, this is like typical AI lifecycle looks like, where you're using the data storage, uploading the data, you are doing a bunch of data processing, then training the model, and then deploying or using the model. uh, in any kind of like AI life cycles, 50 to 60% of the time is required to prepare the data, do feature engineering, and all those like tasks of data processing. Then you have 20 to 25% of the time is required for building, training, hyperparameter optimization, model testing, and validation. And 15 to 20% of the time is used for model deployment, batch prediction, model monitoring, data drifting, those tasks. Yes, it is 15 to 20% of the time, but at the same time, it is as important, this section, as building and training and preparing the data. So you can design a model and host it, but if you don't retrain the model after a while, it will give you wrong information. Then there's no point of using that model. Plus, if you design a model, a lot of times we hear from our clients that, hey, my data scientist has created the model, it is working on his laptop, but he doesn't know, or we don't know how to use it in production or how to connect it in with existing applications. So that is a problem, because you have hired that person, that person has used the data to create the model, but that model you cannot use it. So what happened in general, so whenever you are and like when as I'm gonna talk a bit about like the life cycle, I will talk about few things that I didn't cover last time. Suppose whenever we are loading the data and processing the data, doing data transformation, yes, we are converting the data type, data format, those things, but at the same time we are also like doing some extensive operation, like if there is any missing value on that any row or on that column. So if there is missing value, then we can replace that missed value like empty row with some kind of like median mean operation. That is also like falling under like data processing. If there are suppose some one column that is representing gender, or like if you like applying one hot encoding, it is telling you that like it's a categorical data and how many categories are there. If those categorical values are not balanced, suppose there are four categories of data in this one single column, out of that, like two categories are representing 90% of the data, and rest of the two categories are representing only 5 to 10% of the data, then that is a problem. So you need to know those things, where you will have to like balance those classes to get a good result and good model, and also like to develop an unbiased model. So you cannot develop a model that is biased. Then after doing those like data processing, you do feature engineering. So one thing you need to remember in your mind, 60 to 70% like success of the model that you are training depends how good of a feature engineering that you do. So you can do two types of feature engineering. In one case, if you're using any kind of platform like AutoML, then you can do like advanced feature engineering, where those like tools are automatically trained to create like its own features. Suppose like what does it mean? So suppose if you provide one date time stamp column, so normal feature engineering is just using date time as date time, or date time as like a single values, as a single sequential values, so that you can apply different kind of regression based models later based on what you're predicting. Or by advanced feature engineering could be you're taking that date time stamp and converting it like the date of the week, date of the month, the time, and separate and like the year. So separating that single date time stamp column into 4 to 5 different like columns. So like the week of the week of the day of the week, day of the month, the time of the day, year. So like those are like advanced features, so they fall into like advanced feature engineering category. Then when you do the modeling, even if you are using like normal classification, there are like two types of model that you can use in AutoML like applications. One is deep learning based, learning enabled, and one is classical machine learning algorithms. So if you are using like what is the difference? So like if you're using classical machine learning algorithms, those algorithms are way faster. It will take less resources, and it will be like cost efficient as well. And depending on your data, in most of the cases, it gives a like a good result. If you use like deep learning enabled model, then the thing is, it will take more resources, it will take more time, and also depending on your data, you may get better result, because in deep learning you don't need to do manual feature engineering. It does automatically, but it depends on your data actually. Then after doing the training, like in platforms like Azure, they provide you explanation. So why this model is giving 80% accuracy. So or of each prediction that, hey, I'm 90% confident that this is like class A or class B. So based on which impactful variables it is claiming that. So your like Azure machine learning platform can inform you those things as well. So global importance factors, local importance factors, different kind of like justification as explanation why this model is giving you 80% accuracy or performing well or not, so something like that. So that is also important, because you cannot just take a model and put it into production. You need to have proper justification and validation of or through, and it needs to go through auditing phase, why this model is giving good result or bad result, why you will use it in production or not. And the last one is model deployment. Once you deploy the model, I'm not going to talk too much because we will talk during the demo. Once you deploy the model, you need to know how to use that model. You can use it as a batch prediction or as an API to connect it with your existing systems. Azure Machine Learning is providing API-based deployment, or you can also like use that API connected with logic apps to do batch prediction or those kind of things. But it's not providing anything more. But there are tools like if you are like hearing my if you get time later, you can try Data Robot. So that is another automated machine learning platform or tool that provides advanced model usage or model deployment like features. Like it also deploy your model as an app where you can use it in a web interface, the model you just trained, and test it right away. You can also do different kind of like scenario planning using your model, so that you know why it is giving you 80% result, and based on which variables it's giving you 60% result. And you can also do model different kind of optimization. So what it does, optimization, it takes, if there are 10 variables in the model, it takes 10 variables. For each variable common values, suppose variable A has value of 2, 3, 4, 5. Those are the common values. So the range of values are 1 to 5, so something like that. So it takes all the variables and set a range of each of different values of those variables, and apply brute force approach to find out the best combination of variable values to get the best accuracy. So why we need that one? Suppose you are designing a model for churn analysis, where based on your customer information, this individual customer will stay with your company or not. So yes, you can predict based on individual record that, hey, the chances of churn for this individual customer is 85%. But you need to know what you can do extra to keep that customer. So that kind of like optimization based combination of values will give you the idea why what are the things that you can change. Like suppose you can offer a 20% discount for next quarter instead of like 8% of this quarter to keep that client within with you. So something like that. So those are the things optimization, scenario planning, model as an app is offered by Data Robot tool. You can create a sample like account and play with that one. But for Azure Machine Learning, it deploys your model right away as an API, and also you can have custom model deployment. Plus, you can do blast prediction. Okay. So if we talk about a bit more, suppose this is an Azure machine learning process where just like before, as we have seen, and we will see like a small demo, it goes through the preparing the data, experiment through Azure design machine learning designer section or notebook or even AutoML, and then the deployment sections as well, which is registering your model, building an image of your model, adding all the dependencies and deploying it. So we will mostly see those 2 or 3 sections like as a demo. So as we said, model deployment, why it's necessary? It is necessary so that you can connect your model, the model that you have trained, with your existing systems, and your other like client-facing application will be able to use it. And before jumping into demo, I will just like cover the slide, and then we'll give like a full demo of all the tools. And the second thing that I wanted to talk about is Azure machine learning model monitoring. So why model monitoring? So suppose you have designed a model based on the clothing trend. So you want to find out, okay, like user will input where that person is from, what is the weather there, what is like if he is going out today, what is the purpose, why he wants to go out, and what kind of crowd there will be. Based on those information, you have designed a model that will suggest, hey, you need to wear a blue t-shirt with a black jeans with some kind of like sneaker. So those information. So this is what you want to do. So in that case, what you're doing, suppose you have designed a crawler from Pinterest to get all the information from as a database, or you have used that Pinterest data, and then you have trained the model that can tell the user based on the weather, based on the occasion, based on the location. It tells what to wear, so that we won't have to like think too much. Oh, what I'm gonna buy today to wear, or what I'm gonna wear. So the thing is, the Pinterest data that you have used is like working perfectly in 2019. But if it is 2021 or 2022, where the fashion trend has changed, the Pinterest data has changed. So everything has changed. So in that situation, if you're using the same old model and predicting or giving information to user, hey, you need to wear this kind of t-shirt, then it may give outdated information. So that is the problem. Just like COVID. So pre-COVID, all the models that we had, if we were using that one during the COVID time and giving prediction based on pre-COVID data, then that is biased. So we cannot take that model completely and then use that one. We will have to retrain that model based on the COVID scenario and pre-COVID scenario combined. Again, in post-COVID phase, if we use the same model of pre-COVID and like the COVID phase, we won't get the good result. So in post-COVID phase, we'll have to fine tune again, retrain that one with different scenario of data with different weighted values. So this is the same thing, and those decisions are made based on model monitoring phases or like variables. So model monitoring and data drifting, there I have combined them together. So there are like 3 types of like model monitoring and data drifting cases, like matrices. So they are stability metrics, performance metrics, and operations metrics. So these are the three basic metrics actually. So whenever you train a model, suppose if it is a like a classification model or regression model, so which is telling its class A or B, or predicting a value. Every time there are 10 variables, when you train a model, that model end of the day, end of the training, it also tells, hey, these are the three variables or five variables that are very closely connected with the model output values, and these are the mostly impacted variables. Okay, so now what happens after doing the training? So one thing you need to know, that to do the model monitoring and data drifting, you need to have both the training data and the predicting or production data. So you cannot just get the production data and expect to do model monitoring and model data drifting. You need to combine these two, because you are identifying all the data drift and shift based on the data that you have already used for the training purpose. So for the stability metrics, there are like two types of like data shift we see. One is prior probability shift. Another one is covariate shift. So I'm not going to get into too much details into like statistical methodologies, but what happened? So as we know, different kind of like impactful variables. So what prior probability shift is doing, it gives you the information about the distribution shift, a data distribution shift between predicted output and dependent variable. So dependent variables are the most impactful variables in production and training data. So what happens? So those five variables that are the most impactful variables in training data, we have a distribution graph of those data. Okay, in production, we are getting new data as well. So after a while, we can also like generate a new distribution of that one. Then we kind of like make connect these two, this production distribution of those impactful variables and the training distribution of those impactful variables, and connect them together to see from training and distribution how much it has shifted on the production distribution. So that is the process of like identifying, okay, the data is shifting, it is changing, we need to retrain the model, or we need to do something, or after a while this same model will be useless. So there are some kind of like matrices that we use. So they are usually like PSI, like population stability index, or concept shift, or error statistic based index. For covariate shift, as we have already said, that there are impactful or dependent variables, but there are independent variables as well in your model. So it's the same thing, but not with the dependent variables, it's with the independent variables. So it's kind of like you identify the distribution shift of those independent variable of training and production data. And we sometimes, like most of the time, we say characteristics stability index and novelty index to identify the covariate shift. Then the second one is it's kind of like it's this stability matrix is used for data shifting purpose. And the second one is performance metrics. So you have trained the model, you have put it in production, you are using this model. So this model is telling the user, hey, you need to wear this kind of clothes for this purpose, or tomorrow or day after tomorrow, something like that. But when do you know that this model is good or giving good result, or the concept hasn't shifted completely? So this performance matrix is the one that tells you, hey, the concept that you used before has completely shifted. You need to retrain the model with the new data, and this model, whatever the result it's giving, is giving garbage information. So that is another thing. And again, the pre and post COVID models are perfect example for that one. So the model that you'd use based on the pre-COVID data cannot be used during COVID time, or the model that you train based on COVID time, you cannot use that one in post COVID phase. So you need to know those things. But the ways to identify those models, performance metrics, are root mean square error, R square, case statistics. And the last one is sorry, I need to go back. Okay, operations metrics of model monitoring. So you need to identify, as the model is working in the deployment or production phase, you need to know whether the model is actually doing good or not, from technical point of view. So if like your model can predict like five prediction each second, but your application, mobile or web application, is making 50 calls per second, then there will be like a big queue and of like waiting time. So you cannot let that happen, because maybe after a while like the client application will show that, oh, the model is not responding, or it's not fast enough to generate results right away. So in that case, what you need to do is you need to replicate increase that endpoint, model endpoint as an API, and replicate that one, so that like there are 3, 4, 5, or 10 model endpoints are ready. Whenever there are like 50 like API requests are coming, they can process them simultaneously. Plus, at the same time, you need to like ideally monitor how much time it is taking to process on each endpoint, how much memory it's taking, how much IO, CPU it's doing, disk utilization, system optimization, those as well. So based on those like technical information, you can increase the size of the container that you are using for model monitoring manually, or you can like you can have like a bigger cluster of Kubernetes, so you can add more pods, so that like users can simultaneously use your overall like application or the model that you have trained. So these are the three top like model monitoring metrics: stability metrics, performance metrics, and operations metrics. And like the good thing is Azure machine learning covers all of them mostly, and you can automatically use them from the tool. You won't have to like manually do it. And the same with Azure machine learning data drifting. So we will show right now like a small demo. Like we don't need to like talk anymore. So let's just like jump into the demo. So okay, as we will show three types of like things. One is how to like deploy a model, how to deploy a model from custom how to do custom deployment, and also how to do like check data drifting. So this is my Azure machine learning portal. So like if you are new in this portal, so I will just show you one in for like few seconds, like how to run a model or how to like do a training. So suppose if I just like click automated machine learning, a new one, and select this global AI one, and then next, uh, that is a data that I have already uploaded, and I can just select the existing experiment. Suppose a dataset unregistered something, I will select a column, whatever it is. So, or I can just just upload a data. So let's upload a data. That will be easier actually. So okay, if I just like click from local data set, um, global AI, so two suppose, and if I just click next, if I just like click browse, and on the download I have a train.csv, so I just selected that one. I just want to like use 1 or 2 second like minute on that, on this process, not more than that. So you can see the data is already uploaded, it's nicely showing. We can, you can see there is a problem like column one, column two, I don't know which one is that. So I can just use use headers from the file, so that it's nicely organized. So okay, it's not column one, column two anymore, it's ticker and all the information. So it's like a stock price prediction data set, where we will predict the closing date of each stock based on the date and all the other information. So if you just click, if you want to like remove some kind of discard some column from the data set, you can do it, but I'm just like selecting all just for the demo purpose. And then I can create a profile of the data set as well. I need to select a bunch of like a computation machine, that's it. And you will see automatically it will do all the like stuff. The data is uploaded. Now we are just like creating a new experiment. On that experiment, we need to select whether it's existing. Yes, it's existing. We need to select the target column. We are predicting the closing values of each share. And then I need to select a compute cluster. I can create a compute cluster by clicking it here. We will have to select. I have already created like North Central US. Based on my account, I have like two types of machines, standard this one and standard D4. Suppose I'm selecting this one and creating, and then I need to like create and given like a name of the compute name. There's only one node assigned. I can do like advanced settings, but I'm just like creating that. So you see, it's that easy. It's creating, or I can just like use an existing one because it takes a couple of minutes to create. So and then as I said when I was like explaining, there are like two types of like classification algorithm we can use. One is deep learning based, one is like classic machine learning. So for classic machine learning it takes less time, less resources. For deep learning it takes more time, more resources, but at the same time we don't need that one. We are doing times, as there are time involved, and we are predicting stock price, so we are selecting time series forecasting. Suppose we will do like closing values. Time column should not be the same target. Oh, sorry, they have asked for the time column. So my time column is the date column. Okay, and the target, I have already selected the target column, so I did that mistake. And time series identifier, any kind of like unique value, I'm selecting like ticker. Okay, and that's it. I can just click finish and it will automatically create the run, do all the like modeling and everything by itself automatically. So I won't have to do anything. So, okay, I'm not gonna wait for 45 minutes to finish this like operation where you can see it hasn't started. It will start, it will do everything. It takes 30 to 40 minutes. But I have already trained the model yesterday. Suppose this one, I will just go there. So it is already trained. After the training, you will see something like this with the data guards. So it tells you all the like data information if there are like missing values or short series handling. Sometime it also tells whether each values of that series or the data is having proper proportion or not, or proper like following proper ratio or not. And all the models, as it's an AutoML platform, it automatically trains lots of models by itself, and you select one. So okay, as we are gonna see the deployment, so not gonna like see anything else. So voting ensemble is the model. We can just click that one. Uh, we said at one point that there are explanation. We need to explain why this model is giving these results. So this tool also like shows this kind of explanation. If we just click it, okay, let's go back and like show the model explanation from the other point of view. From this one, then if we select the model view explanation, it expands and show you the full explanation of why this model is, it's still in preview phase, is giving this kind of
Hi,
results.
Rahat.
Yep.
I'm just wanted to, if you please make your browser a little bit zoom in so that I can see it correctly. Yeah,
Okay. Is it better?
perfect.
Perfect. Thank you.
Yeah.
So this, okay, it's a bit slow. Okay, so when we were discussing that, it tells you the global importance factors, local importance factors based on model performance. So you can get all the information from this like section. Plus, you can also use data explorer. So okay, we are not going too much into that one. I just wanted to show. So once we train the model, we can just download. So if I just click download, it has downloaded a bunch of things. So what it has downloaded, if I just click and show, um, I'm just showing my screen. Okay, so it has downloaded this package, and that package is three values, three files. One is model.pkl, one is coding file, one is a conda env. So every time we train a model, we need so we get three values. Conda env represents the YAML file that shows. If I just like open that one, that will be easier. So suppose this one, the same thing. Conda YAML shows all the like to create this same environment. What are the like libraries we need to install? What are the dependencies? Suppose Azure ML, Pandas, scikit-learn, those things. So even if we are doing a training of our own custom model, we will need this file, and we can easily create that one from Conda environment. Every time we train a model, after doing the training, once we are confident that this is the model that we will use, we pickle the model. It's kind of like we store that phase of that trained binary model in a binary representation, so that we can store that representation and use it for prediction purpose of that from like that model is trained on that database. And the last one is scoring file. So it is also like generated automatically by the Azure AutoML platform. So it tells like which values or what are the process of doing that model validation, model prediction, and those things. So you can just go through that one. So scoring file is the first file that when you do the API call, your API goes through this file to get like send the like JSON request to that PKL file, to that model, so that it can prepare a response and send it to you or give it to you. Okay, so every time we
Um,
do a training.
Sorry to
Mhm.
interrupt, but I guess we can see only the Azure portal. We cannot see the folder actually. So
Okay,
sorry to interrupt, but
no, no,
yeah.
no, perfect. Like, sorry, let me just like reshare that one because that is weird. Um, Screen window, screen two. Okay, now it should work. Can you see my screen?
Yes, much better now.
Perfect.
Thanks.
Okay. So, okay, sorry for that one. So let me just go through again. So when I click download, I have downloaded these three files in a package. So one is Conda, one is model, one is scoring. So on that Conda, if I just like show, these are automatically generated files that is given by Azure portal. So it represents what are the like dependencies or libraries that I need. Second one is model.pkl file that I have already explained. So this is the binary representation of the trained model. And scoring file is a Python script. So it also like shows like how the like API will communicate with the PKL file to prepare the consumable request and response. So that one. So even if we are doing like a custom deployment or our custom model, we will have to like collect these three models. Once we, if it is we are doing a training without using the Azure platform, we will prepare that model.pkl. We will use Conda environment to create that YAML file. And also we will manually write this scoring file, which is a Python file. Okay, so if we move forward, as we have already done the training, we have the model, how to deploy that model. So there are two phases, two ways. One is automated machine learning. If we do it using AutoML, we can just, it's very easy, just click deploy. We can just select like suppose like INF inferencing 3. We can have select Azure Kubernetes service or Azure container instance. So what is the difference? So when it's container instance, it is like a standard container that is already ready based on the Azure ML like training platform, and it can automatically like very quickly spin it and then add your model on that one so that you can do prediction right away. And it's like a single like a one core 1 gig like a container, I guess, and it's always constant. But on Azure Kubernetes service, if it is like a production environment or a dev environment where you want to do massive testing and those things, you can create a computational cluster on Kubernetes service and then have 20 nodes, 30 nodes, and then create that one. So for this purpose, I didn't create any cluster. I'm just gonna use Azure container instance. So you can see there are not much information I need to give, and I can without like enabling authentication, I'm just deploying that one. So it is that easy to deploy, to do like simple prediction and everything. But as I said, I have my own model. I did not use Azure automated machine learning to train the model. So in that case, what can I do? I will just click register model. So it's like a new model one, suppose, then I will have to select the framework. So as I have designed the like trained the model by myself, so it is a custom model. So that custom model needs to be developed in one of the framework. And literally, as your machine learning is covering all the popular frameworks, which is like XGBoost, TF Keras, TensorFlow, PyTorch, PySpark, Onyx, H2O, Chainer, all of them. So the model that I have just trained is based on AutoML. If it was based on something else, then I could have selected that one. I can select select even like a CPU or even like a GPU based machine. If my model is a TensorFlow image processing machine, like a model, I can select those one. So I need to select framework version. So in my case, my framework version is 1.00. Then it's asking me, hey, model file. So which is a model.pkl file, the pkl file that I have generated. So if I just select that one, suppose this one, and click model.pkl, done. I can add tags and everything else, but for now, I just want to register the model. That's it. So I will click next. So you can see a new model NM1, new model one is registered, and it's still like working. Okay, if I go more, there is nothing much. It's just like it's showing me the artifact, which is like model.pkl, and the endpoint is not ready. There is no endpoint, and all those other information. I'm like, okay, so the model that I have just uploaded, I want to deploy that one. So now it will, when I click deploy, I will have to provide extra information. So in NM1 deploy, then again the same thing. Though it's a custom process, but I will have to select one of them. I'm selecting SCI. Then it will ask me, hey, as it's a custom model, it needs those two files. One is script file, the scoring file, the Python script that we got, we can generate that one by ourselves. And the second one is the conda dependency file, because based on my conda file, it will create a new container with all the dependencies, and then it will add the scoring file at the top, and then it will use the model.pkl file in the bottom, so that whenever I expose the container as an API, whenever I make a like API call, the API takes goes to the scoring file to the PKL file to create a proper response. So I need to select the conda environment, so YAML file, and that's it. It is working. It's perfect. And when I click deploy, it will take some time to deploy, but you will see, okay, it is deployed. So right now, nothing is happening. You can see the success. NM1 deployed, deployment started successfully. It takes 5 to 10 minutes to deploy. If I see previous deployment, yesterday I did one small deployment. So let's just like look at that one. So it was like test one, I believe. And yeah, it was test one. It was the same thing. After doing the deployment, it shows in your endpoint. So the test one was test 1M. So if I click that one, then after doing right now, the new one that we started, which is NM1 deploy. So if you just like click on that one, you can see NM1 is deploying. Deployment status is transitioning. It's not done. It's working. If I just make it a bit bigger. So it's transitioning, and compute type is ACI, and all the other information. Right now you can see REST endpoint is null. So what does it mean? It means that the REST endpoint is not ready. It's still working, and there needs to be a Swagger URI as well. And it is, as I said, it is like a default configuration of ACI as your container instance. So on that CPU, there is like zero point 0.1 CPU plus zero point 0.5 gig of memory. It's mostly for testing your model. So once it goes through the process, it takes few minutes, like 20 to 30 minutes. So after that, you will see something like that. As I have deployed a model yesterday, you will see the model deployment status always healthy. If your model is having issues, hey, the model cannot make any more prediction. It is getting too many requests, then it will tell that it's not healthy, or there is something else. It will tell you right away. It tells you, gives you the RESTful endpoint of API to make API call from any kind of like application. It also gives you a Swagger URI. So if you just click, you can see the Swagger file, and the same way the CPU and memory. So all those things are actually handled by automated machine learning or Azure machine learning platform. You won't have to do anything. So what it shows is you have the data, you want to train it using AutoML, you can deploy it as well. And after the deployment, you can use the model as an API to connect with your mobile or web app. But even if you don't use the Azure machine learning platform or AutoML platform for the training purpose, you use that entire like your data on your own local environment, TensorFlow or some other like framework to create your own model, but you don't know how to deploy that model. You don't want to like create a custom deployment infrastructure on Azure or some other cloud platform. You can still use Azure Machine Learning with your Conda environment, scoring file, and model.pkl, and host it on like easily with few steps. And not always you will have to use CPU based information like container. You can also select GPU based container like based on the account you have with Azure. So that was the first thing I wanted to show. And the second thing I wanted to show is the monitoring. So there, they have also added recently that part. So once you train the model, as I said, the monitoring is important to identify whether this model is usable or not, whether there is any data drifting or data shifting is happening or not, whether you need to retrain that model or not. So uh, either you will do it manually, all those like data analysis, or you will do it in a like a scheduler like a way where every week you will take the training data and also last 1 weeks of production data to make a comparison between the data shift, concept shift, and all those other information that we have already discussed. So on that one, if you have already like loaded the data set, so suppose there is a it's a preview data set monitoring option, you can just select that one. You can just create monitoring. Then you can target data set. Suppose time series version 1. So one thing it doesn't show, the new data set that I uploaded, it's not there. Why? So once I do the training and then I deploy that one, I need to do some prediction. And only after it enables this data monitoring phase to do data monitoring or drifting. If I don't do prediction, then it remains disabled. So I did a couple of like prediction on time series. It's just to enable that one. So once you select this target data set, you will click next, and you can also select like manually like days of start date to end date to make a comparison between the baseline training data and the new production data to identify the data shift, to find out there is data drifting is happening or data leakage is happening. Or you can just select like a new data manually by yourself. So if I select a new data which is not the same, then what happened? Then it will tell you, okay, there is no common column between target and baseline dataset, so I cannot use that one. So in my case, it's time series version 1. If I just select that one and click next, uh, you see it's not giving me that error anymore. And I will just select like a name, suppose whatever. I will select the features, which features I want to make comparison. I need to select like a computational target because there will be a lot of like computational processing. I will have to like monitor enable, or I can like do it manually. I can select the frequency. Every day I want to test it, once a week I want to test it, or once a month. So every week it will do like a comparison between the training data and the new production data and tell me, hey, your data, like your model is giving like bad results based on the concept shift. You need to do a like new training. The latency, you will also select the latency. So you will specify the hours in latency based on how many hours like later you want to do it. It could be 5, 10. If you want to just report, you can also select an email. So every day automatically it will work as a scheduler. It will run this operation and send you an email, hey, your data is working perfectly, no worries. Or your data is not working perfectly, you need to worry or retrain the model. So you can do that one. And you can also like select a threshold like based on 50, 40, 20, 10. The basic is 20, the very general thing for threshold, that hey, whenever there are like 20% data shift or concept shift, it will give you identify that one, send you an alert or email as well. So once you create that one, uh, it is the entire process there. You won't have to do much manually. So it will just create and give you like a proper representation of the data, what is happening, what was happening, and all those things. So if I just select case one, you can see, because I didn't make any prediction, it's not showing much, but it will show all the information that I am supposed to see. to consider like this model is doing good or bad. So you can see model monitoring time series. Right now, no data, but all the other information based on monitoring, full summary of drifting magnitude, top drifting feature. So if there are like 10 features, 5 are most impactful, 5 are independent. So these are the two features that are shifting the most, so that like we can like identify that one. Plus all the other feature wise, all the other information that I need to like feature distribution, where the feature is changing, feature details and everything, like drift magnitude by feature, drift magnitude by trend. So all those informations by automatically by itself. So it's like a new feature in Azure machine learning platform. So still it's in preview, but you can try that one. So this represents the model monitoring, data drifting part, which is under that model deployment section. So that's it mostly about my presentation. So I didn't want to like talk too much about like model training and those phases. I just wanted to like tell as much as possible regarding how to deploy the model, how the custom model deployment works, and what happens if you deploy the model, how can you use that model, what is data drifting, what is model monitoring, why you need that one, why doing a model training is not everything, model monitoring and deployment is also very important. So those things. So thank you for attending my session. And if you have any question, you can ask me. Again, if you want to connect with me, you can follow me on Twitter or connect me on LinkedIn. So thank you. If there is no question, I'll wait a bit. I will, yeah, just end the presentation after that then.
Hey, hi.
Hey,
Uh, how are you doing?
I'm doing good. You?
Yeah, fine. So I am a bit confused about inference cluster and Azure Kubernetes service. I'm bit it's related to deployment target, right? So yeah, I'm a bit confused on that. Can you clear it?
Yes, obviously. So when you were like deploying, there were like two things that were showing. One is ACI, Azure Container Instance. One is AKS, Azure Kubernetes Service. So ACI is just for testing your model. So it is one container with one CPU and 500 MB of RAM, and it is constant. So you cannot change that. So whenever you train the model, just to test that one, you will select ACI, and it is boom, it's ready as an API so that you can use it. Now you have used that one. Now you want to put design a production environment. So for that production environment, so you need to like have more like cluster, like not only one container, you want to have 20 containers. So you will get into compute section, you will go into inferencing cluster, you will create a cluster of Azure Kubernetes service with 8 core machine and like suppose two like 20 gigabyte of RAM and 20 nodes. So in that case, what will happen, based on the requirements that you need, you will select that AKS. Okay, it will be a production environment. So it will be a, like a Azure Kubernetes service. On that service, there are 20 nodes. So instead of having just one container, you can have replica of that same container into 20 different like nodes, so that it can handle more requests. So these are the two like difference.
Thank you. Thanks for clearing that out. It was a bit confusing. So
No, no, yeah. It was also confusing for me as well at the beginning. Oh, why do I need ACI? Why do I need AKS? It depends on your production environment, testing environment, dev environment, UAT environment, those things.
okay. Yeah, because I'm giving AI 900. So I viewed your previous video on the
Yeah.
this. Yeah, so that's
Okay, perfect. Any other question?
Hey, Rahat. One question. So currently in our organization, what we are using AWS
Mhm.
for creating models and things like this. So if we try to go to Azure, is there a way we can find out the cost of what we would be deploying? And we
So
already know how many. Yeah, yeah. Sorry, go ahead.
Yeah, perfect. So if you use, that's why I showed that custom deployment option, where if you have already trained the model, you have the model that is generated from AWS, you can just download that one, the model environment file, scoring file, and the PKL file. And then you will have for the costing, there are Azure calculator, like a pricing calculator. You will have to like
Yeah,
identify how many requests you are getting every hour, how many each pod, how many requests it can process, and then you will have to like create a like representation. Okay, you need to have 10 pods with like 20 core nodes, like 20 core CPU, or this much information to be live always. And then you will have to like on that AKS as your Kubernetes service, you will have to create that representation and then like upload custom models for that one, so that it will give you like how much time you are using, how much money you are consuming, and all those things. And it's you can easily do that.
great, great. Thanks for that.
Yeah. Okay. If there is no other question, then I will end it here. Thank you everyone for attending it. I hope it was useful, and let me know if you guys have any question. Thank you.